Well, hello, wonderful students. This is going to be quiz 110 help video. So I wanted to show you the search bar for those of you who maybe haven't noticed it before. I'm going to type in quiz 110, see what happens. Nothing happens. Well, a positive, zero search results. How about just 110? That was rude. A bunch of stuff. Nearpod. Ah, okay. So would 110 quiz work? Okay, well, there you go. So don't put the quiz in front of the 110, put the 110 in front of the quiz. Or you can just type the 110 for whatever quiz you're looking for. Again, I try to link them under grades tab right there, okay? So be sure to check that tab throughout the school year. It's where your grades are coming from. I will post what I think is useful up there, okay? A direct link back, help videos, that type of thing. So keep an eye on it, and yeah. Let's get to work. So I just wanted to show you the search bar. I didn't notice it for a while. Maybe you guys are like, it's right there. But yeah, let's see. All right. Look, that's okay. Look at it. So now, right now, this is the highest one. But we still need a few more students to take it. So we'll see how we're doing there. All right. View, copy. Okay, we did this one in class. So watch the recording if you have the comedian one for the class. Adam, let's talk about Adam, or do I want to talk about, Mia. Let's talk about Mia. Why not? Mia needs to bring at least 25 pieces of fruit to the school picnic. She is bringing both apples and oranges and was told to be sure to bring more than 10 apples. Let X represent the number of apples and Y represent the number of oranges. They're going to ask us to select the inequality. So the nice thing here, when I scroll down, you're going to see all of the inequalities. So you're not going to be asked to create them from scratch. What you're being asked to do is identify the right symbol, which is why we went over it in class, to the inequality. So we're looking for those phrases, those key phrases, right? Okay. At least 25 pieces of fruit. So we have X's and Y's, apples and oranges. So X plus Y, what is at least? Okay, if ever you get stuck here, just try out some symbols. Less than or equal to 25. Can she bring 24? Because this side would be 24. No. Greater than or equal to 25. Can she bring exactly 25? Because that's what we're checking right now. Yeah, at least 25. If she brings 25, she's good. Can she bring 26? Yes. Aha, that's the symbol we're looking for. It's a very important strategy to pick some solutions and put them in there, especially when it's not a precise one answer. Try out a couple options and see if it makes sense within your story problem or whatever problem you're working on in the future. Okay, she is bringing both. That's a key phrase when we think about inequalities because we have this option of X greater than 0, Y greater than 0, X greater than or equal to 0, Y greater than or equal to 0. So here we talked about it in class, and the idea is, can it equal 0? Like, do we have to bring apples? Do we have to bring oranges? Can I bring all apples? Can I bring all oranges? If I can bring all of one kind, then apples could equal 0 and oranges could equal 0. But if I'm bringing both, that means neither one can equal 0. I've got to bring at least one apple, one orange, maybe a piece of an apple or a piece of an orange, however you want to think about it in your problem. Okay, and then finally, more than 10 apples. So X is apples. More than is that symbol. Not more than or equal to, not at least 10. More than, strictly more than 10. So she's got to bring more than 10. So 10 and a half, 10 and a bite, 11, right? So let's go look for those down here. Nice. So now why wouldn't we pick, oh no, they didn't give us that option. Never mind. So we're good. So that's the strategy that you're going to use when you have a word problem. Just try to identify, can it equal exactly 25? Can it equal exactly 0? can it equal exactly 10? And put it in the word problem and see if it makes sense with the phrase you were given. Well, Miss Velez, I guess we're gonna pick those. So that's all right, because what's happening here is, again, we're just checking the symbol. So maybe it'll make more sense if we have the answer. So they're already highlighted for us. That's nice, but they won't be for you. And you might have this problem, you might not. So Miss Velez, both X gray, Y red bricks. So both colors of bricks, meaning she's not going to have 0 exactly equal to 0 of either one. So we know it can't be this one. Gray bricks cost 45 cents. See, that's the number part. That's the coefficient in front of the variable, because for every brick of gray we buy, we'd spend 45 cents. So if I buy 10 of them, then I spent $4.50. And similarly for the 58-cent bricks. Okay, so that's a common strategy to set up equations. You're going to see it often. And even when you do this if you're actually trying to figure out the cost of something per item, you would just find out how much for one and how many you want to buy, and then you did it. So you do algebra in the world around you. You just may not think of it as X and Y or variables, but they are. All right. She can spend up to 200. There we go. That's the phrase we're looking for. Up to 200. Can she spend 201? No. So we know it's not the greater than. Can she spend 190? Yes. It doesn't say she has to spend all of it. Can she spend all of it? Can she spend the full 200? Does up to 200 mean she can spend the full amount? Yes. So that's where this symbol comes in, the or equal to. It could be exactly equal to 200 or less. She wants the number of red bricks to be less than half the number of gray bricks. So in this inequality, they set it up for you. Red bricks, less than half the number of gray bricks. And again, it has to be greater than 0 because we're using both. Less than half the number of gray bricks. X is gray bricks. So less than half X. That's exactly what this symbol is. That's the less than symbol. So hopefully that helps. If it was this one, it would say less than or equal to. It would say at most, because that could be the at most symbol as well. At most, half the number of gray bricks, meaning it could equal the number of gray bricks, like 50-50, or less, but at most, right? I know it's confusing. At least and at most, they're kind of flip-flop with the sound of the words versus the symbol. But just plug in those ideas, put real numbers or imagine it in your mind, and it will help you, okay? It's actually one of the mathematical practices we talked about, to think abstractly and quantitatively. That's just a fancy way to say, hey, bring the numbers to life, okay? Bring them to life. What do they mean? A tire company. So if you were in Help Lab with me, we worked on this problem several times, and I'm tired of it. If you weren't in Help Lab, then that's a little inside joke as we were working through this one. So let's look at a different one. All right, hockey. So we did the tire question in Help Lab. We did the candy question, which is variation 1 in the live session. So now let's talk about baseball cards. And I want to go through the steps very specifically for linear programming. The very first thing you're going to do is identify your constraints. We're lucky we get them right here. All right, I'm going to use my face to kind of block the answers. Haha. Look at a good use of it. All right, there we go. We have them set up for us right here. They're just not in inequality form. They're in the equal sign. They're an equation, not an inequality. So we need to read our word problem and replace the equal sign with the inequality symbol that they've described. So let's try to do that. If you didn't have this here, you would have to just read it and try your best. So Carmelo is selling his hockey and baseball card collection. Hockey cards X sell for 3 cents. I'll type in that in a second. Baseball cards Y sell for 5 cents. The number of hockey cards Carmelo sells is at least 6 times the number of baseball cards. So that's this one. So X is at least So that's x. We got to be careful with the variables. Excuse me. Hockey card's x is at least, so it can be greater. So see how I'm putting the large symbol towards the x, right? Because x is what can be greater. So that means sells at least 6 times the number of baseball cards. So 6 times y will be less than x. See if that makes sense. He has at most 525 cards to sell. At most means x plus y is less than or equal to 525. Now, for those of you who looked at the Progress Learning 109 lesson that I tried to assign to help us have that extra support, they did it wrong. And the thing that he explained in the video that was wrong was merely looking at this symbol and then shading. The problem with that is we need to be careful of the sign. See how that's a plus y? That means when we solve for y, the inequality symbol will stay the same direction, meaning we'll shade below. If that was an x minus y, then when we solve for y, we'd actually end up flipping the inequality because we'd have to divide by a negative number to get y by itself, and then it would flip-flop the inequality and we're shading in the opposite direction. I understand because I did the same thing in the flow of explaining this problem in Help Lab, and then I noticed why they explained it wrong. It happens to all of us. Math is not always just about getting the right answer. It's about thinking. So we always have to be thinking, including teachers, instructors, and curriculum writers. But just be assured, rest assured, everybody makes mistakes. The cool thing about math is we can check them and we can prove it. We can say, I disagree with you, and I can prove it. So that's kind of fun. So notice that it's okay here, again, because it's going to stay the same direction. So I know I'm going to shade less than, which is below. It's below, okay? Let's make it a little less. So I'm going to shade below this line. And actually, I'm going to shade below this line. Why do I have to shade? In linear programming or in any inequality, you have to find the possible solutions. The possible solutions are, again, where the overlap is. So look, as I shade below here and I shade below here, I can see that this is going to be what we call in linear programming my feasible region, this little triangle, because that will be the only triangle that is overlapped. This area doesn't count. This area doesn't count. It's not needed, even though this area would be shaded because we're just shading underneath that whole line. You can see this in Desmos. Desmos keeps everything shaded, but you're looking again for all of the overlap because that's where all of the inequalities are true. That's where they're all true. Okay, think about it. All right, so that's the first step. We need to set up our constraints. We did it. We set up our constraints. They graphed it for us. They kind of helped us with the equations. We found our feasible region. And now we need to figure out our objective function and if we're trying to maximize it or minimize it. And we'll go through that next. What is the maximum revenue he can make? So revenue, profit, money. How much money can he make? Carmelo, well, he is selling. Change again. Let's go darker. 3 cents for a baseball card. So does it make sense that I could just write 3 cents times X because every baseball card will be 3 pennies? And 5 cents times Y because every hockey card will be a nickel. That's our objective function. This is what we're looking to optimize, or in this case, maximize. So we are trying to find the combination of baseball and hockey cards that would give Carmelo the most profit. What we do from this point is we look at the vertices, the corner points. That's where the max and min will be found in a linear programming problem. That's pretty cool. Look, otherwise there's all these points in between here that we'd have to check. But that's not what's going to end up happening. Why does it work that way? I don't know. That's not a question I've really looked into. Why would that be true? Why do we only have to check the points of intersection? I know we have, I'll leave it there, open-ended for you to find out. So our options now, or our strategy now, is to plug in the various X and Y values from our graph. This is graphically, if you did this Algebraically, it'd be a little bit more time consuming, so I highly recommend using technology to help you solve linear programming problems, because also in the future, you will be using technology to solve linear programming problems. Okay, 450 is the x value, 75 is the y value. Let's go check it. Hey, they give us a calculator. I'm going to use this calculator because I have my draw it tool. You can use Desmos, that calculator, but all I'm going to do is 450 times 0.03 plus 75 times 0.05 equals $17. So this one equals $17.25. Let's do the other one. 0.03 times 525 plus 0.05 times 0. I guess I need to do that. This one down here is $15.75. Oops, 75 cents. So we're looking for the maximum value, the maximum profit. So it's going to be this combination where you sell 450 baseball cards and 75 hockey cards so Carmelo can make the most money. And that's what you would tell him if, say, you were working for him. You'd be like, hey, boss, this is what you should sell. Boom. You just got a promotion. $17.25. Where do these numbers come from? I don't know. Maybe if you plug in this one, I don't know where that would come from. So let's see. 5 times, 0.05 a nickel times 525, $26.25. Have no idea where this would come from. There's no combination on there, but that's okay. You know how to do this now. Same steps, maybe different numbers. Read the story problem, use the resources they give you, and then just kind of think about it. In the candy bar one, we had a great observation where you just could kind of inspect based on what was happening in our story problem, and you maybe didn't have to do all of those steps. But notice how our feasible region was down here. Without going through the steps, you might have thought, oh, I can just use this one. You couldn't in our problem because it wasn't in our feasible region. Okay, so keep that in mind. Question 4. Hey, we did this in class. The only difference is I used a different triangle, but I did ask you about possible solutions. Key ideas, it's got to be in the gray area. So we also went over how to plot these. First things first, we need to figure out what X and Y represent. Platinum is X, silver is Y. So that's nice, right? They put it in order. Remember, we go this way first. Let's go over to 10. And let's go up to 10. Oh, see? So we go up to 10. Nope, it's not in the feasible region. It's not a solution. 12 and 20. 12 is like between 10 and 15, right? It's like somewhere in here. So we go up and we go up to 20. So somewhere right here. Yep, we're done. You can check the rest, though. We're going to do that just for practice. 16 and 30. So we go over to 16, somewhere like right here, up to 30. Okay. Nope. 25 and 20. 25 and 20. No, see, 25. We go up. 20. Okay. Couple of things to notice. This is the only, that did not change the color enough. Let's make it like prettier. Okay. This on the line and in the gray, because they're solid lines, is the feasible region. Okay. Nothing on the lines outside of the feasible region count. And if one of the lines were dotted, which they're not, but if it was a dashed line, then on that dashed line, no solution would be there either, because that dashed line says, hey, points on this line don't actually satisfy what we need. So that's a little bit of a review and just to kind of emphasize some of the big ideas about systems of linear inequalities. Okay. Last question. Whew. Apples. Okay. We're going to do the same thing again. I feel like that's the same graph I used. Let's do a different graph. Remember, just because you saw that was the top answer does not mean your top answer is right if you have that variation. They do change the order of where your answer is, so you're going to have to go through the process. All right, it's the same. Looks like it's the same, so we'll just go back to that one. Possible red apples and the possible green apples. Let's scroll down. Again, only in this and on only on these lines and in this triangle are the possible solutions. So let's just do some green. Red apples, 40 red. Okay, so here's 40. Oh, wait, X is red, Y is green. You got to check that. That matters. Up to 12. So look, here's 10. 12 is somewhere between there. So yes, it's in the gray. Check. Let's check the rest for practice. 30. So again, X first. 30. Up to 18. 5, 10, 15, 16. Oh, wow. That one is really close. But it's still not really in the region. So no. 35, 30. Let's do it. 35 up to 30. Oh, no. Clearly out. Okay, 40, 35. So here's 40. 30, 35. No. So this is the only possible solution. That's clearly the solution. One was really close. So maybe it is a good idea, depending on which order you have your solutions, to just check them all. And the one that is the most correct will be the correct answer. All right. Thank you for watching. I hope these help you. Reach out if you have any questions.